Hi, and welcome to this session, Integrate Testing into DevOps to Deliver Continuous Quality. My name is Mark Lambert, VP of Strategic Initiatives at Parasoft, and today we're going to walk through the best practices for integrating testing into your CI/CD pipeline, as well as some of the things to watch out for. But let's go ahead and start and jump in. Let's talk about how testing and how quality can be built into that pipeline, and we'll start by actually talking about quality itself. So we really should recognize that while we as an industry have been talking about quality for years, decades, it is still a big problem. And actually, Cisco recently released their cost of poor quality report. And this was a redo of the 2018 report. And it actually estimates that there's approximately $2 trillion worth of cost associated with poor software quality within the US market. That represents about 10% of GDP. So it's a big problem. It's multifaceted. There are many different places where we have those quality issues. And really, we should recognize that quality has become a senior level executive issue in organizations. And in fact, these three well-known brands, Walmart, United Healthcare, and CVS Health, have all talked about quality in recent annual reports or investor conferences, and talked to the need to be able to deliver high-quality experiences as part of their innovation roadmap to ensure that they have business success. So it is critical that we build quality software, and it's critical that we can release that software fast. So how do we do that? How do we kind of balance the two and deliver quality at speed? Well, really, the key to this is the concept of continuous testing. Continuous testing where we're able to provide immediate and ongoing feedback throughout our DevOps process, throughout our incremental agile deliveries, injecting quality processes at each stage of the pipeline and using those to ensure that we are accelerating our releases, performing incremental release functionality at the velocity we want, but making sure that it meets that quality gate and those quality criterias. Now, we're going to talk about this today. We're going to talk about what the different practices are and how we can embed it in. But I want you to think about, really, as we go through that, don't lose sight of the goal. The goal is to help us accelerate the successful delivery of our software projects. And really, we have to remember that acceleration is a key driver for many organizations. And that is going to, if you like, it's going to come at a cost. We want to make sure that we're delivering high quality, but we're delivering it fast. And we also want to deliver the scope. So there are really several challenges associated with that. And as we go through today's conversation, we're going to talk about how we can reduce the cost of achieving high quality, which obviously security comes hand in hand with that, as well as compliance as well. Often in traditional software development processes, each of these three are approached much later in the SDLC. Compliance is usually the last sign-off before it goes out of the door in a regulated industry or in a regulated application area. Security is similar. We are seeing organizations shifting that left now, which is great, but still there's a security sign-off at the end. And obviously in the traditional waterfall-centric development practice, QA or quality happens all the way at the end of the project once we've finished delivering. So the first thing we want to do to reduce the cost of quality is to shift it earlier in the cycle, or to use the term shift left. Our goal here is to achieve testing in sprint. So we want to go through our testing process. We want to do it in parallel with the development of new functionality. We want to do it there because it's going to be quicker, it's going to be cheaper, it's going to be easier to remediate as well, because the time between defect detection, or should I say, the time between defect injection and defect detection is much closer, because we're going to be doing the processes earlier in the software development lifecycle. And we're going to be talking about those and the practices and how we can structure those. Second, we want to do it faster. Obviously, DevOps is all about how can we automate as much as possible, remove the bottlenecks from the processes, and automation is a key to ensuring that we can actually do our testing and validation faster. But we also want to execute it continuously. This is where the continuous testing concept comes in. And here is also where environmental constraints become a challenge. And again, these two are fundamental components to what we're going to talk about today. The last one is a little bit more novel, and we'll touch upon this at the end. You want to test less. That's right. You don't want to test more. You actually want to test less. You want to spend less time testing, both in the creation and the maintenance, but also you want to spend less time in the execution of your test scenarios to focus in on the things that matter of what you're working on in the current sprint. And we'll talk about that strategy at the end of today's presentation. Okay, now, obviously there's going to be a lot to digest today, and there are a number of different ways that you can test and validate technology or software deliverables as they're moving through your pipeline. Probably many of you are familiar with the testing pyramid here. It's very popular within Agile circles. Very much Michael Cohn and Martin Fowler are big proponents of this. In essence, it's how do I organize my test portfolio, if you like. What it means is I have a lot of granular tests, unit tests or tests at the service layer, the API layer, things which give me the ability to get a broad test coverage. And these granular tests are going to be easier to diagnose, they're quicker to run, but they obviously have a more technical aspects associated with them. We'll touch upon that in a second. And then what we want to do is really want to minimize the tests that are at the higher level, the end-to-end tests, the ones that take a lot of time to run, they're complex, but we still need those. This is a pyramid, not a trapezoid. So we want to make sure that we focus those into the use cases that are most important to run through those end-to-end cycles. And kind of all of these techniques kind of complement each other. You'll notice here also, we talk about manual testing as well at the tippy top of the pyramid. Here, what you want to do is leverage your business analysts, your domain experts, but do it in an effective way. And we'll touch upon that at the end today if we have time. Now, this is the foundation of your test automation strategy, the testing pyramid, but I view that there really is a layer of the pyramid that is missing, and that is the foundation that you're building your testing practice on top of. If you don't have a quality code base or quality code that's being pushed through your delivery cycle, you can't test quality into an application. You have to build it in, and this is where code analysis comes in. Now, I'm not talking about basic linters here, readability, maintainability, so kind of the simple patterns. They are valuable, don't get me wrong, but that's not how you kind of build that really solid foundation and build actually the business case and the ROI for doing these practices. You need to focus on the deep type of code analysis that uncovers reliability and security issues. And again, we're going to go through each of these in a few moments as we talk about our pipeline. Bottom line is, by applying these practices, we have a quality practice or a way of building continuous quality into our code base that is both scalable and easier to automate and easier to maintain the automation as well. Now, however, when we talk to organizations, most people will identify with an inverted pyramid or an ice cream cone. And this is because intuitively, applications are intended to be easy to use. So therefore, by definition, it's easier to validate some functionality when you go through the UI versus when you're trying to exercise the application at the code level. So it's quicker to define. However, at the top part of the pyramid, it's actually very hard to automate initially, but also maintain that automation. UIs change a lot. Web pages have locators which can become dynamic depending on the implementation frameworks you're using, and it becomes very difficult to maintain them and difficult to diagnose. Moving down the pyramid, obviously this is where we have the tests which actually don't have those challenges. They are much quicker to execute. You don't have to worry about the entire infrastructure of your complete application because you're isolating. But they are much harder to create. It requires more technical resources. So we have to identify technologies and approaches that can really kind of limit or reduce some of those issues. And we'll talk about those as we go through today. Now, actually, at Parasoft, we have the opportunity to talk to many different organizations at different levels of maturity. And what we actually find is it's really a little bit more like a martini glass than an ice cream cone. Many organizations are either struggling or skipping past the concept of API testing. Here is where I'm testing my APIs, my REST APIs, SOAP APIs, the underlying infrastructure of my application. It really is the sweet spot to the testing pyramid. It gives me the ability to create something that can be easily diagnosed by the development team. It gives me something that I can do really powerful early stage performance and security penetration testing. But there's a lot of unknowns around API testing and about how do I actually model different use cases and how do I kind of bridge the knowledge gap between the code and the end user experience. And again, we'll touch upon a couple of techniques today that we can leverage, or technologies that we can leverage to actually address those issues. Bottom line is, if you're identifying right now with an inverted ice cream cone, don't worry, you're in good company. Many people are like that. Organizations are still struggling. You might identify yourself as an ice cream cone with a cherry on the top, which is another phrase that I've heard where basically, yes, we started to reduce our manual testing practices, but we have focused on automating the UIs. And that obviously is not a strategy for success. So what do we need to do? How can we kind of build these different techniques into our pipeline? And how can we accelerate the delivery of quality and build it really in so that it's a continuous process? Now, there are a myriad different pipeline diagrams out there. I'm going to leverage this one here. It's actually pulled from the Scaled Agile framework. And we're going to talk through the different phases of developing, building, and then test and verification. Now, before we start jumping into the different techniques, though, we have to remember this all starts with a work item, a user story, or a user story derived from a requirement. There may be some tasks to fix a defect. These are important because we're going to come back to these at the end to help us understand how well we've tested our application. But as you start working with one of these systems, this is the thing that kicks off your process. And before you really start developing, before you start doing any work, you have to actually start defining how you want to validate that functionality. And this is one of the keys to ensure that you really are building quality in, or building an in-sprint testing practice in place. So the first thing you're going to do is you're going to define your story. You may optionally define your acceptance test at this point. Some organizations do or don't. I see that difference depending on their stories. I think, to be honest, it is a best practice to go through defining those acceptance tests up front. But one thing that you have to do during that planning stage is you have to decide, how am I going to validate that the functionality was implemented correctly? Am I going to do a manual test scenario, or am I going to do an automated test scenario? Now, there are both. I said it's a pyramid, not a trapezoid. So there are use cases where manual testing is more appropriate than automated, but what you want to be shooting for is that the vast majority of those are going to be automated tests. As we move up the pyramid, you're going to say, okay, well, I've got my unit testing. You're typically more of a developer-centric testing practice, testing at the code level, leveraging frameworks like JUnit or NUnit in the .NET world. We're going to move up to go through API testing, and this is where we can start to do things kind of more at an integration level as well. API tests, as I said, are really the sweet spot of the testing pyramid, in my opinion. It really gives a good communication mechanism between the role of dev and QA. It gives you the ability to have dev and QA collaborate. Then as we move up towards the top, we get to kind of the UI-centric testing practices, and obviously Selenium is the de facto standard when you're talking about UI testing practices today. And again, we'll touch upon each of these in a little bit more detail as we kind of move through the process. Now, I did mention earlier, though, that really before we start testing, we need to start considering how we're going to build good quality code to start with in the first place. And this is where deep code analysis comes in. Focusing on security and reliability, finding things like tainted input values is a key area of protecting yourself for the majority of security hacks. You want to leverage industry standards like OWASP, CWE, and CERT for security, or AutoZone and MISRA C for reliability, especially obviously focused within the C and C++ world here. And then the last point is you want to blend, or you want to consider the concept of prevention versus detection. So if we look at the chart on the right-hand side, this is where we're talking about where defects are typically introduced. So 85% of defects are typically introduced at the coding stage, but where they're identified, the orange line, is much closer to the actual release, most typically, which is obviously where the cost, the red line, starts to rise exponentially. What we want to do is we want to use these practices to shift left and push down the number of defects. So shift left the detection of the defects, and then push them down in the first place by making sure that at coding time, we are reducing the number of defects that are introduced. And this switch from a from a detection to a prevention model is really where you're going to get a massive value or massive ROI from code analysis. As I said, you want to go deep here. You want to be not just doing kind of like the just the basic linting stuff. That's a good start, something like a Sonar Cube. You'll see on the left-hand side, I'm referencing the Parasoft products that can actually help with these different things. So JTest is our Java code analysis and unit testing technology. C++ test is the same for C and C++. And then dot test is our technology for doing security code analysis of .NET code bases. So once we've got our solid code base in place and we've got the quality code, we can start moving onto the testing pyramid, and we can start moving up. And here we're going to actually start with, as I said, unit testing. So what this is going to do is this is going to really give us a solid foundation for our testing practice. They are quick to run, they're granular, they're easy to isolate. You'll get a very quick feedback in your part of your CI, part of your CI/CD pipeline. They are also a good practice in that you're actually going to end up with better code design and architecture if you implement unit testing up front. One of the challenges that I often see organizations doing is they're struggling with taking an existing legacy code base and rolling in a unit testing practice into that. There are some different approaches you can take there, and certainly Parasoft JTest actually can help you kind of put that regression framework around your existing code base. But obviously what you really want to do is to build unit testing kind of into the practice from the start. We'll talk about measuring completeness at the end here. We'll actually talk about code coverage in a few moments. So let's kind of just move up the pyramid, and let's talk about the automated functional testing. And you'll see here, this is both in the test end-to-end as well as in the verification phase of my pipeline. The key is creating tests that I can reuse. These tests, you're going to want to touch broader functional business flow of the application, and you're going to want to have these tests reusable during the different phases, but also you want to actually reuse these tests not just to do functional verification, but verification of the non-functional requirements like performance testing and security penetration testing. So use code analysis to build a secure code base to start with, and then you're using these types of tests to validate and verify that your security mechanisms are working, and also verifying and capturing performance issues earlier in the process. If I can reuse my functional tests, I can actually do continuous performance testing, re-leveraging that work, and it gives me the ability to identify potential performance problems much earlier in the software development lifecycle. Now, one challenge when I start doing this shift left performance testing is the test environment itself. So here, I often run into constraints or complexities associated with my test environment. Maybe I don't have access to the backend system that I need, or the access that I do have only supports a limited amount of bandwidth or transactions. Here's where the concept of service virtualization can help. So what service virtualization is the ability to simulate and emulate backend dependencies. As I said, this helps address the issues when you don't have access to it, but it also helps address the issues when you can't put the backend system into the state that you need. So it might be a microservice that is fully Dockerized and I can deploy it in the cloud on demand, but I can't get the data into the specific scenario that I need to be able to test a particular use case. By building simulations and by building lots of granular simulations, I can switch them in and out. They basically become supercharged mocks or stubs that are used or reused for functional and non-functional verification. So here, this is actually the technology from Parasoft. Parasoft Virtualize can help you with this. We're not going to go into service virtualization too much today, but it is covered in other sessions that we've presented as well. So go back and check the Bright Talk channel. I'll also say here that one of the challenges I mentioned earlier around API testing is the ability to understand how those APIs are actually used. So, when I develop an API, I typically create a Swagger document or Open API document, and I can leverage that to kind of articulate what the APIs look like and the use model for a specific API call. But what it doesn't do is a good job of explaining how several APIs are used in conjunction with each other to deliver a piece of business functionality. This is often the challenge that many QA organizations face because they're trying to unravel the use case. Here, this is where Parasoft actually has unique technology in the market where we're able to monitor the interactions that a user has with the application, either manual interactions directly through the browser or by monitoring your existing Selenium scripts. We're able to decompose those into the underlying API calls and then apply our machine learning algorithms to stitch those API calls together into a test scenario. So really addressing that problem that we talked about earlier, which limits the adoption of API testing. Now, the last thing on this slide, the piece around the automated UI testing, as I mentioned earlier, UI tests are typically easier to understand, but they're hard to create and they're really expensive to maintain. This is the challenge that many people face when it comes to Selenium. So Selenium is the industry standard for a reason. It's very, very powerful. It's mature. It's well adopted. There are other frameworks like Cypress out there, for example, which are also increasing in adoption. But the challenges that you face are basically that you have to create the code in the first place, and you need to create the code in a way that's maintainable moving forward, which actually the concept of the page object model helps address this problem. And then also, as you're maintaining moving forward, locators and things like that change on the pages. This is where Parasoft created a Parasoft Selenium product that helps address these issues. But as I mentioned, if you're building your Selenium tests, leveraging the concept of the page object model, this is actually where you can build some of that maintainability into your test framework from the start. So we've got a whole bunch of testing embedded across our pipeline now. We now need to start aggregating that data together and bringing it all into a centralized place where I can actually start getting visibility into my whole pipeline and really make decisions about where we should be spending time to improve the quality. Because one of the things that you may or may not care about is if a particular test fails, if that's not a business impacting or business critical impact, do I actually want to halt the release for that? Now, some people are going to say yes, because it's a test failing, you should halt the release, but it really depends upon the business priorities. And it also, the only way you're going to get that visibility is by bringing all of that quality data together into a centralized view. Now, one piece of that quality data is something called code coverage. And here you can see that we're actually capturing code coverage from multiple types of testing practice. So as we look at the graphic here, 65% is our total code coverage against, which is the parts of the code that are executed by the automated tests. But I have, or should I say, by the testing practices. But I actually have three types of testing practices here. I have unit testing, which is at 63%, functional testing, which is at 29%, and then we even have some manual tests here at 23%. What you want to do is you want to get visibility and understanding about how much of the code base was actually exercised during your testing practices, and you want to combine those things together. Now, obviously, your different testing practices are going to overlap with each other. So you have to combine them together, identifying the overlaps and identifying where the gap is when you take that into consideration, which is where we get the 65% number here in the middle. Now, this will point me towards where I am incomplete from the point of view of my testing practice, from the point of view of how much of the code was exercised. What it doesn't tell me is it doesn't tell me the quality of the code base. That's actually a key point that I want to make, because many people look at code coverage as a quality metric. Yes, it's a quality metric, but it doesn't tell you the quality of the code. It actually tells you the quality of your tests. It tells you how complete is your testing practice. But if you remember when we started down this, we talked about the work items, the things that we're actually working on. Code coverage doesn't actually tell me what how I'm doing from the point of view of testing the things that we are working on. And for us to be able to do that, we have to connect our tests and our user stories or our requirements together. Now, when we do that, we actually can start to look at a secondary type of coverage and a secondary type of quality metrics. So here we can start looking at test coverage. We can say how many of our user stories were exercised as part of our testing practice. And here we can see in this particular example, there's 98% test coverage, meaning that out of the 45 user stories, 44 of them had a test of some form, either manual or automated. We can also see what the status of those user stories are with the chart above. So we can see that there are a number, looks around about like 10% of the tests or user stories have failing tests associated with them. Probably about 5% or 8% looks like maybe have tests which didn't complete for one reason or another. And then we have about, well, looks about like 65%, 70% of user stories that are fully passing tests. Now we can further segment this further and actually start to ask ourselves the question is like, well, okay, of all of the user stories and all of the requirements, what about the ones that I'm working on in this sprint? And this is where we come back to the third piece of what I was talking about before. So I said, test earlier, test faster. So we've got the earlier testing practices, we've got automated pipelines now, so we're testing earlier and testing faster. But how do we test less? Because obviously what you're doing now is you're building out a whole bunch of different testing practices. Oh, let me just go here. There we go. There we go. Okay, so what we're doing is we've got a whole bunch of testing practices now, which are building out our portfolio, but they're going to be taking a long time to run. So what we want to do is we want to optimize and optimize our process so that we're focusing on the things that matter to us right now. I'm not saying that we're never going to test everything, but remember what we're trying to shoot for here is integrating into our DevOps pipeline and integrating into performing in-sprint testing and maximize our testing activities early. So here, I want to introduce the concept of smart test execution. What we're going to do is we're going to take the tests that we have and we're going to execute a subset of those, focusing on the changes in our application, changes in user stories or requirements, or changes in the underlying code. And there are really two approaches for smart test execution. The first is what we refer to as work item-based execution. So here, what we're saying is identify the user stories that you're going to work on. Well, obviously, that's part of standard sprint planning. Then as you create the tests for those user stories or requirements, correlate them back to the, create the tests and correlate them back to the requirements and user stories so that you can focus your automation on validating the things that have been worked on in sprint. So as I build out that connection between user stories and tests, I can then say, okay, if I have 2 user stories, 1 and 3, that are being worked on in the sprint, I'm going to execute these 3 specific tests and get feedback immediately as to what user stories, or the quality of the user stories that have been worked on in the current sprint. However, there is a secondary technique because there's going to be something mixed here. This is actually pretty quick to do. You're just basically subsetting your tasks as long as you have the practice in place of doing the correlation. It's actually relatively straightforward to actually start identifying which tests you need to execute. But the challenge often is that my code base is actually pretty complex. And what I really want to do is I want to understand the impact of the changes in the code base to the tests themselves. So here what I want to do is I want to actually map the coverage and the relationship between the individual tests and the underlying code base. So this is something that Parasoft does through our proprietary coverage engine, and we're able to understand what parts of the code base an individual test has touched. We can then analyze the code base or the WAR file that's deployed as part of your pipeline. We can fingerprint those and identify where the changes were made, which in turn identifies which tests need to be executed. So in this simple example, you can see that the 3rd change towards the bottom actually does affect user story 3, but also affects user story 4 as well through the correlation. So here we would identify that there would actually be two additional tests that we want to execute as part of this process. But here what we're doing is we're focusing down the test suite, and we're focusing down the test suite to give us as quick feedback as possible earlier in the pipeline. So this kind of takes us back to the beginning. It's all about getting quick feedback and getting continuous feedback as I'm moving through my DevOps process. So this starts with building in testing and quality practices from the beginning. So here, how can I help, or how can I start building in a testing process into the ideation phase of my DevOps cycle? Well, obviously, this is where you can leverage technologies like behavior-driven development, BDD. I can start defining my feature files, which document what the behavior is that I want. And then I can start implementing test automation that actually provides building blocks for us to quickly get, in essence, a certain level of test automation for free. I will warn against using BDD at the end of the process because I feel like that's really where you're using it backwards and you're not getting the true value of it. BDD and TDD are both practices which are best leveraged up front. And really that's where TDD comes in as we start getting into our building phase. So when we're building the software, we want to actually start with trying to deploy test-driven development practices, building unit tests before we actually start implementing the code. When we then are implementing the code, applying the deep code analysis focused on static application security testing as one of the key business value advantages of applying deep code analysis early. We then start moving towards the end of our building phases, and as we're moving into kind of the additional phases of the cycle, starting to leverage API testing, things like smart test execution to get the quicker feedback as part of my CI/CD pipeline. Test data modeling is also an interesting avenue here where we can start to address test data issues early on in the process. Then as we're moving from CI into CD, this is where we can start to leveraging early stage performance testing, service virtualization to manage my test environment. And then once we actually release, there's the opportunity for us to actually further reuse those functional tests to provide ongoing runtime monitoring of my ecosystem. So there's a lot to consume here. There's a lot to digest, I realize. So What I'd like to do is to invite you to go ahead and put some questions into the question box. We've got a few interesting ones I'm seeing popping up right now, but I'll leave this up for a second. So if you want to learn more, first of all, obviously you can check out the channel. We're posting other videos on going deeper into some of these topics as well. We also have a live demo coming up in later in March or at the beginning of March, where we'll actually touch upon each of these technologies and kind of showing you a quick kind of whirlwind tour of how they work. And then we also have here a white paper which covers a lot of these topics as well in more detail around continuous testing for DevOps. Okay, so with that being said, hopefully that was useful for you guys. Got a couple of questions here, so let me just end the slides and then switch to that questions view. Okay, I've just lost it. Click. Okay, there we go. All right. So, okay, so some good questions. So what first step can we take to integrating testing into the CI/CD workflow? Okay. I would probably take code analysis as the first step. That's actually the best, kind of the easiest, if you like, or the most frictionless way of implementing some quality practices into your pipeline. It is a quality practice rather than a testing practice, and it usually has it's relatively small amount of adoption work for the team. One of the things you want to be very careful of when you do the code analysis is making sure that you select the right rule set. You don't want to select, so for example, in our tools, we have about 1,000 or so rules per product. You don't want to select all 1,000. You actually want to focus in what is your business challenge, what are the things you're trying to achieve, and select a rule set which is manageable, creating a manageable volume of data. That's something that we often help organizations doing, is tuning what things they want to put in there. Then as we start moving into the testing part, I would say try and shoot for getting the API testing in place. Unit testing is very valuable, but it does require developer attention. UI testing does require a lot of overhead. You're probably doing some of that already. API testing is the sweet spot, which many organizations just are not grasping right now, or kind of struggling to adopt, should I say. And that would be an area that I would focus on. It's also an area where obviously Parasoft can help with our SOA test product. Can exploratory testing be implemented into a DevOps pipeline? Okay, so exploratory testing is a very good use of your domain experts. So the tippy top of the pyramid, the manual testing practice, I often talk about how that is very good for identifying UI UX issues, because what a human is good at is being creative and understanding usage patterns. Does this really kind of meet the needs or the implicit needs of the requirement? What a machine is really good at doing is checking the same thing over and over and over again. So building a regression test, validating particular numbers, particular formats. Regression testing is perfect for that. That's what a machine is great for. If you want to leverage a human, one of the best uses is around the usability or exploratory testing, kind of testing beyond the boundaries of what was defined for the current in-sprint work. Now, there are some technologies out there that will do automated exploratory testing, kind of like, if you like, randomly accessing and expanding across the application. They're useful, but it's not a substitution for automated regression or manual exploratory. It can give you areas where you may want to investigate further, but I wouldn't use them as strictly as a quality gate to your pipeline. I would more use them as a piece of informative feedback that goes into the process. Okay, I saw another one which kind of related to this area. Yeah, okay, there it is. Okay, so what's the role of visual testing? Okay, visual testing is where what I'm doing is I'm looking at the UI and I'm verifying, has the UI changed in ways that I'm not expecting? So actually there's a company, Appletools, who's a partner of Parasoft, who does a very good job of this. Visual testing is a great way of providing you that kind of like integrated, automated view of what parts of the application potentially, as I said a moment ago, it has an unintended consequence. It's also a pretty good way of getting a basic kind of regression suite against the application. It can run very, very fast as well, which is very powerful. I think Applet also have a product called something like ultra fast grid. So you're actually able to validate a whole bunch of different UIs and a bunch of different interfaces. Again, it's not a substitution for regression testing. Regression testing, you're going to be focusing on the data and the workflow. The visual testing focuses on what the appearance of the application is. And again, it's a good complementary to your manual domain testing experts. So your domain testing experts now don't have to spend a lot of time making sure that the logos are in exactly the right places. Again, it's a good thing that a tool can do. Okay, so a couple of other questions popping in here as well. So let's just take a quick look at those. Okay, so okay, yeah, actually, I think I answered that one a little bit. So yeah, another question around exploratory. Yeah, how can we shift those to the left? Yeah, so there, as I said, there are some technologies out there, but I wouldn't. I would kind of view them as kind of guiding technologies rather than things that should be treated as just regression defects. Okay, looks like I have 2 more questions. Let's see. Okay, I'll leave the metrics one till later. Okay, so we are not able to complete in sprint complete testing in sprint. What recommendations do you have? Is it okay to test? Sorry, is it okay for testing to go into the next sprint? Okay. All right, so that's actually a good question. So many people are kind of like this is one of the new industry terms is in sprint testing, is like, okay, how can I move my testing practice so that I'm at the end of my sprint, I'm truly done? Because this all comes down to what the definition of done is for your agile organization. Is your definition of done that development are done, or that it's done and being verified? It really should be the second. But one of the obvious challenges is if a sprint is 2 weeks and development have something that's going to take them 2 weeks for them to do the implementation, you have no time to do the testing. So there's 2 things that you have to take into consideration. The first is during planning, you have to make sure that you've allotted time for doing the testing. And don't just default to the manual testing, otherwise you'll be always playing catch up and you'll be always have this technical debt in play where, oh, I kind of need an automated test, but you're onto the next thing already. I'm okay with the exception of that slipping into the next sprint, but you have to be very, very careful with that because that's a slippery slope. What I'm a much bigger fan of is making sure that the test automation is a shared responsibility. So if, for example, we have something coming that we don't think our test experts are going to be able to create an automated functional test within sprint, then really we do need to make sure that the development team are creating a unit test for that. They should be creating unit tests anyway, but that represents a clear gap, and we should say, you know what, we have to have it verified, which means it has to have manual or, it has to have a manual or automated verification, but then it has to also be automated in some way. I think that's a really good kind of definition of done for the in sprint, and then you can allow some things to bleed out if you're saying, well, it has to be automated at a functional level, and there might be some that you'll let it bleed into the next sprint. It's just kind of like reality, is purist versus reality, right? But what I would say is don't let that become the norm. So don't let it be that at the end of every sprint you've got a whole bunch of stories that are pushing out. That's not a good thing. Okay, I'll just pick this one more. We have a couple of minutes, so let's say, what are the key metrics we should be tracking for software quality in the dashboard? Okay, so every one of the testing practices that we talked about today has metrics associated with them. You also have part of your overall ecosystem, like your Jira ticketing system, source control, where you can also get metrics as well that can further refine that quality data. So if we think about each of those, right, you should be looking at static code analysis data. You should be looking at the number of violations that have been introduced within the sprint. So to do that, you want to be able to say, here's my baseline build, and what has been the changes since my baseline build. And at Parasoft, we choose two builds. We have the one which was for the last build of the prior release, and then the build at the beginning of each sprint. So we're basically benchmarking against two numbers each time. So we can see, we can make sure that we're clean in this current sprint, and then we can also see how we're doing related to the overall kind of release arc, if you like. And that's a key way of measuring the metric to make sure that it's adoptable. Also, you can leverage different risk models and security severity scores around static analysis. Now, the same is true for each of the testing practices and associated coverage. How am I doing versus my baseline? Don't just look at code coverage at that high-level macro. We only touched on code coverage very briefly today. But in the same way that test impact analysis can tell me what tests I need to execute because of the changes, I should look at the code coverage changes as well and saying, am I touching the modified code? And that modified code versus my baseline of the sprint versus the baseline of the last release. And they're really some of the key metrics that you can monitor. And then, as I said earlier, about mapping coverage into requirements traceability is another component to start bringing the systems together. So you got the changes in the code base that you get from the source control, use that to filter down the data, leverage baselines so you know that you're improving versus history, and then leverage traceability back into requirements management or agile planning systems as well. Okay, unfortunately, we run out of time. Got a couple more questions, but we'll answer those offline. Thank you very much for joining this session, and do remember to check out the channel. Check out the rest of the things that we got posted on there. Also, the Parasoft website, and I'll actually just bring up these resources again at the end here, so you can kind of check out our live technical demo in a couple of weeks. Actually, that's next week. And then also check out the white paper for continuous testing. Okay, so with that being said, thank you very much for your time today. Really appreciate it. Look forward to seeing you virtually in the next session. Take care.